Hi everyone, I'm Jackie and this is my molecular portfolio about the antibiotic Cefalexin. Cefalexin goes by many different names. Its brand name is Keflex, its generic name is Cefalexin, and its chemical name is listed below. Some general information about Cefalexin. Cefalexin is used to treat infections of the respiratory tract, bacterial infections, skin infections, and urinary tract infections, or UTIs. This is an antibiotic that is used to stop the growth of bacteria. This drug can be taken by most adults and children, and an interesting fact about Cefalexin is that this medication can be passed through breast milk when mothers are breastfeeding. Continuing from our general information about Cefalexin, this antibiotic has some known interactions with drugs or medications. Some of these drugs include metformin, multivitamins, warfarin, zinc, sodium pycosulfate, and alcohol. Here are some don'ts about the antibiotic Cefalexin. Cefalexin should not be used by people who have kidney problems, or if they're allergic to Cefalexin, or if they're allergic to any known antibiotics. Next, I'm going to be drawing the line bond skeletal structure for my antibiotic and its lone pairs. Cefalexin starts out with an OH, which is bonded to a carbon, and that carbon shares a double bond with oxygen. Starting out from that central carbon, we're going to be drawing out another bond, and this bond is connected to a carbon ring which shares a single double bond. So I'm just drawing out the rest of my ring here, and the ring is broken up by a single sulfur, but it continues on and is broken again with a nitrogen. Going back to the carbon ring and drawing another bond, and then going back to the nitrogen and building this square structure. So my molecule has a hydrogen that is pointing away from the structure, and it also has an NH that is pointing towards the structure, so I'm just going ahead and drawing that. Next, I'm going back to the top of the box structure and drawing a double bonded oxygen. Going back to the NH, I'm drawing another bond and another bond, then I'm going to add a double bond to the carbon that's in the middle, and this double bond is connected to an oxygen. That same carbon is also bonded to a NH2 that is pointing towards the structure. So I'm going ahead and drawing that as well. After drawing that, I'm going to be drawing another single bond, and that single bond is connected to another carbon ring. This carbon ring shares 3 double bonds, so I'm going ahead and adding them to my ring here. And after that, I'm going to go ahead and add in the lone pairs. The octet rule states that each atom that is not a hydrogen needs to be surrounded by 4 pair of valence electrons or 4 bonds, so I'm going back to all of the atoms that do not fulfill the octet rule and adding lone pairs as necessary. Starting with the OH, I'm adding in 2 lone pairs to the oxygen since it only has 2 bonds. And then I'm going over to the other oxygen and adding 2 lone pairs as well since it only has 2 bonds. Going to the bottom of the sulfur of our carbon ring, I'm adding in 2 lone pairs as well because the sulfur only shares 2 other bonds. And for the nitrogen as well, I'm adding in a single lone pair since this only has 3 bonds. Next, I'll be going over to the oxygen and adding in 2 lone pairs because it only has 2 bonds, and same for this other oxygen here, I'm adding in 2 lone pairs. After that, I'm going to be adding a single pair to the NH since it only has 3 bonds, as well as the NH2 because this only has 3 bonds as well. And that's the finished line bond skeletal structure and its lone pairs for my molecule. Next, I'm going to be going over the expanded structural formula as well as the Vesper theory and its molecular geometry predictions. So I'm going to be highlighting all of the electron central atoms that have a bent molecular geometry. This oxygen is considered bent because it has 3 electron groups, even though it only has 2 bonds. It has a single lone pair, as well as this sulfur here. It has 2 bonds, but it has a single lone pair. Next, I'm going to be highlighting the central atoms that have 3 electron groups, which is trigonal planar geometry, and that goes for all of the carbons here in the carbon ring, so I'm just going ahead and highlighting them. This carbon has 3 electron groups. This carbon also has 3 electron groups. So I'm just going ahead and highlighting all of the carbons that have 3 electron groups, which includes all of the carbons here in this carbon ring. Next, I'm going to be highlighting all of the central atoms that have a tetrahedral molecular geometry. What this basically means that the central atom shares 4 electron groups. So I'm going ahead and highlighting some of the carbons here because they share 4 bonds, which is 4 electron groups. After I'm done highlighting all of the central atoms that have a tetrahedral molecular geometry, I'm going in and highlighting all of the central atoms that have a trigonal pyramidal molecular geometry. This basically means that this has 4 electron groups, but it has only 3 bonds and 1 lone pair. So this goes for all the nitrogen atoms, since they share 3 bonds, but they have 1 lone pair. And that concludes the Vesper theory molecular geometry predictions, and this is the end of my molecular portfolio about the antibiotic cefalexin.